Yeah, this is the last part of diode chapter. So let's see. Yeah, we looked at the rectifier, peak detector. Actually, this peak detector is just this circuit, right? This is called the peak detector. Yeah, in the previous cases, we used the periodic signal. But how about the non-periodic signal? If my VST, if my VST changes, VST waveform is non-periodic, something like that. So it's irregular, okay? Then what's my VO? So assume my diode voltage, on voltage is zero point 0.7 volt, okay? Or maybe this is zero point 0.5 volt because it flows current very little at zero point 0.5 volt. Then my VO initially 0, so it will follow this voltage and then stays there, and then follow there, stay there, follow there, stay there, right? So it finds the peak voltage, right? So during this time interval, diode voltage is less than zero point 0.5 volt, so diode is off. Okay, only this time interval diode is on, right? That's why this is called a peak detector. Peak detector. Yeah, what was the clamping circuit? Clamping circuit, if I change the location of capacitor and this diode, see, this is my input, and if I have something like that, so this is my clamping circuit. Yeah, this clamping circuit just put 0 volt, either minimum voltage or maximum voltage to 0 volt, right? The DC, so this is my periodic signal. Yeah, this is my periodic signal, right? It should be periodic for this one. Periodic, periodic, periodic signal. Then, all the DC voltage is applied into this capacitor. Yeah, so here, this one, so it should be positive, right? Say, if my Vs has some DC value like that, so my Vs is a periodic signal swing between minus 4 volt and plus 6 volt here. Then, when Vs becomes minus 4 volt, this diode is on, right? So this capacitor will be charged to minus 4 volt there, right? Yeah. And this is minus 4 volt, and then diode turns on, capacitor voltage is finally reach minus 4 volt there. And then my VO will be 4 plus Vs, right? So then my Vs is, my VO will be something like that, 0, 10, right? This is my VO. Clamping circuit put 0, I mean either minimum voltage or maximum voltage to 0, right? It just DC restorer. This is called sometimes DC restorer, right? The DC voltage it just regenerate the DC voltage. If I put diode in this direction, my VO should be negative, right? My VO is something like that. Maximum voltage clamped to 0. Okay, so let's go to the some different circuit. Voltage double up. Yeah, see, we just use that peak detector. Yeah, see, for this one, we have two circuit here. Yeah, that one and how about what is the second circuit? Yeah, second circuit is, say, if I draw second circuit, how does it look like? So, first circuit, I know, see, yeah, so, see, this will be, this will remain at 10 volt DC, right? Because, see, there is, this amplitude is 10 volt, right? And then the diode turns on whenever it goes to peak voltage, right? So my VO will remain at the 10 volt, right? My VO, 10 volt. How about the bottom circuit, the lower circuit? The lower circuit, say, the lower circuit is actually same circuit, right? So for the lower circuit, I can redraw. I just cut, redraw. Where is my VS? So here. So this is my VS, right? In the opposite way. So here, see, this diode turns on when this VS becomes minus 10 volt, right? So when VS reaches minus 10 volt, something like that, minus VS is in the minus 10 volt, so current flows, and then it will charge this capacitor voltage to 10 volt. So from here to here is a 20 volt, right? 20 volt DC. Okay, question? No? Yeah, similar thing. Similar thing. Yeah, see, this is a clamping circuit. Yeah, this is my clamping circuit, right? So because this voltage fluctuates between plus 10 and minus 10, then when does this diode turns on? Minus 10, right? When Vs is minus 10 volt, this diode turns on. It charges this capacitor, charge this voltage, right? Yeah. When how about this one? Oh, this is very similar. What is this one? You know, uh, yeah. Again, is it VS? Yeah. For the bottom one, when this diode turns on, yeah, minus 10 volt, right? Is it plus 10 volt or minus 10 volt? Is it right? Yeah, minus 10 volt. When it's minus 10 volt, current flows in like that, like that. So I have some current pass there, right? So it will charge this capacitor voltage 10 volt because current flows like that through this diode. Okay? How about this diode and capacitor? Yeah, this is another peak detector. Then for this one, I have to derive the voltage drop across those two, right? This can be voltage input to this peak detector. So what's this thing? Yeah, see, this is 0. I know this will be charged to 10 volt, right? And then how about this voltage? This voltage, see, I'm talking about the voltage drop between those two diodes. See, I will see the voltage drop is plus 10 volt plus Vs. This is my Vs, plus Vs, and then something like that. Voltage drop across this one is 10 plus 10 sine omega t, right? So it swings between 0 and 20. Okay. So when it reaches 20 volt, it turns on this diode, charge this capacitor to 20 volt, right? So I have 20, 10 here, I have 30 volt here. Not very difficult. Yeah, question? No? Looks like many of you are lost in the middle. Question, ask question. Yeah, question welcomed, eh? Welcomed. How do you like welcome? Am I right? Questions are welcomed. This is big bird, eh? Big bird 하품. This is rabbit, right? Rabbit goes somewhere. Questions welcomed. No? How come? Alright, let's continue. More complex thing. But if you keep on doing that, actually, they are the same circuit. See, if you look at this one, this is a voltage quadrupler. But if you compare this one, see, this is here. This circuit is there. How about that circuit? That circuit is here. How about this part? That part is there, and this part is there. Oh, it is the same circuit, right? So let's see. The upper one looks more convenient to look at it. Yeah. How come I have a 4x there? So I may have this is a 10 volt, minus 10 volt there. And then I may have say 20 volt here, 20 volt here. Then I have a 40 volt there. So it is a quadrupler. Okay. Then how can I generate the 20 volt here? See, when this diode is turns on, yeah, it will charge this voltage into 10 volt, right? In this direction. So how about this peak detector? Yeah, voltage here is just 10 plus 10 sine omega t, swings between 10 and 20, right? Because it's a sum of those two. Then, see, this voltage will go to 20 volt when it becomes 20 volt, you see? Okay. How about this voltage? Well, this voltage is, see, this is here 10 volt, 10 sine omega t minus 20. Oh yeah, the voltage drop across there is 10 volt, 10 sine omega t minus 20, right? Oh yeah, it is 10 sine omega t minus 10. Hmm? So it's, what is this thing? Oh, this is minus 20 to 0, right? So when this voltage is minus 20 volt, I mean, when this becomes 20 volt, minus 20 volt, it will turn on this diode and this capacitor voltage will reach 20 volt there, right? How about that last part? The last part, see, I have to calculate the voltage drop between two nodes. Say, so I go around, this is a plus 20, is it plus 20? Yeah, plus 10, 10 sine omega t, and minus 20. Okay, so this is a plus 20, plus 10, 10 sine omega t, minus 20, right? So this is only 10 and 10, this is 0 to 20, right? So this voltage can go to between swings between 0 and 20. When it becomes 20, it will charge this capacitor to 20, right? So it's a 40 here. Okay. Question? No? Question? Oh, you raise your hand. Both hands, you. Ask question. You, yeah, because I saw you raise your hand. Not both hands. Just ask one question. 요렇게 쓴 거요. 예, DC죠. 왜냐하면 캐패시터 볼티지가 DC거든. DC에 얘는 변하지만은 캐패시터 볼티지는 DC에 넣어놨잖아요. 아까 피크 디텍터가. 그래서 여기서 저항을 달아서 빼내버리면은 좀 떨어지겠죠. 리플이 생기겠죠. 보답 사이클에 또 보충해주고. Okay, some sigma spice simulation result, it really goes approach there, right? Yeah, see, you can find it similarly. Oh yeah, how come I got the same thing here? Dixon charge pump. Oh yeah, this is on review, right? So wow, we should take a quiz 2 earlier. No? So we have a quiz 2 next week, right? Friday. So actually we didn't decide yet. So we talked about the uh, rectifier. Oh, this is a regulator, is not. This is actually rectifier, right? Rectify. This rectifier converts AC to DC. That's a rectifier, right? Actually, regulator is, this is wrong. Regulator is, say, I have a AC voltage here, AC input. I have a rectifier here. Yeah, rectifier is just this one, right? This is my rectifier. My rectifier. And then I have a regulator. After rectifier, I have a regulator. Say, this rectifier output has ripples, right? Those are ripples. Ripple. Ripple is a wave, right? Ripples. So this regulator reduce this ripple. So the regulator output will be very flat, very small ripple, right? It may have a non-zero ripple, but very small. Regulator reduces the ripples. So it's almost like DC at the regulator output. Okay, let's talk about the regulator later, next week.